Welcome to Network Capital, Nuno. Tell us a bit about who you are and what do you do for a living?
Yeah, thank you, Utkarsh, for inviting me to be here. It's a great pleasure and a delight and an honor. I really admire your work, the things that you've done with Network Capital. It's quite a privilege to be here speaking about some of my research. So I am a historian of science and a research fellow at All Souls College, Oxford, which is, as you know, the only college of Oxford that does not have students. So it's a research-only institution. I study early modern science, so the times of Galileo and Newton, and how the new science, the modern science, was formed. So this is a very important period for that time, as you know, the names of Galileo and Newton just explained. But there's many other people involved in this process, and that's what I'm trying to uncover.
So tell us about your early years. What was your training, and how did you get drawn into what you do today?
Yeah, so I was born and raised in Portugal, in Lisbon, and I was very much a science and engineering guy. So I went to the top science school in Portugal, which is known as the MIT of Portugal, where I studied for a degree in physics, and I got a bachelor's and a master's. And I was fascinated by the universe that we have, and I was especially working on cosmology, and I worked on the accelerated expansion of the universe, got some of that published. And then I felt another calling, which is I was reading a lot about the history of science, the history of physics. And I, first of all, was realizing that many things that we take for granted are actually not the way they went in history. And I thought maybe I should, give it a try and try to pursue a PhD in this topic. I realized I was not going to be a physicist for various reasons, but I could still follow the path that you followed, the business world. And I've decided to pursue a PhD in the history of science, which I guess you are now also pursuing, Utkarsh. Not in the history of science, but in other things. So the intellectual life always draws us in.
It does.
And so I went to Johns Hopkins University, where I did a PhD in the history of science. And since then, I had different positions in Europe. I had a research fellowship at Harvard in Florence, beautiful Italian Renaissance villa, where I worked for a year, wrote the final chapter of my book, and then finally got this position at All Souls, very prestigious, and I'm very thankful for that.
Congratulations. So tell us a bit about your book. What is the core idea of the book? How did you decide the structure of the book?
Yeah, no, so I mean, the book draws in from the research that I did as a PhD student, but it changed significantly as I was trying to make, these ideas, to convey these ideas to a broader public, mostly historians of science, but I think these questions are so relevant to so many people that I've been finding, different kinds of people reading my book, which I find fascinating and surprising, but I'm very happy with it, of course. So this is a book about a 17th century scientist who was trained as an anatomist. Born and raised in Copenhagen, gets his MD at the University of Leiden, but it's really a research-oriented MD. So it's like an MD PhD, as you can think of in modern terms. And then he moves on to Paris, which is a vibrant place for science in the 17th century. The Académie des Sciences, one of the very first scientific academies of Europe, is being created right now. He gets a job offer to be one of the first fellows, like Christian Huygens, very famous in physics, or Domenico Cassini. But he ends up rejecting that because he has a better offer at the Medici court in Florence, basically to perform the research that he was doing, which was not just simple anatomy, but he was using a lot of mathematics in his descriptions of the body. And I think that was really innovative. And my book tries to show how important that was for the mathematization of nature. That is, the use of mathematics to understand nature, which is something that modern science takes for granted. All science is like that today. But it was not like that back then, and it was highly debatable. And Steno is one of the leading actors in this, just like Galileo was using mathematics to describe the motion of projectiles. Steno was using mathematics to describe muscle motion. And like Newton, he was using the same laws to describe the motion of the moon and the fall of objects on Earth. Steno, too, was using the same laws and the same principles to think about the human body, but then also about the Earth. And that's really where the book kind of culminates, because he has this incredible insight that stones found on mountaintops are just, or not just, but they are teeth of sharks. So they are fossils, right? And how can I explain to other scientists, to the scientific communities, to the Republic of Letters, right, that stones or teeth of shark can be found in dry land very far away, removed from the ocean, right? And so he develops this theory about how the Earth formed, that it took many years. And by looking at the strata you can discern certain things about the history of the Earth. And these principles that he used are still taught today in basic geology courses as the Steno principles of stratigraphy. And just before passing the word to you, just to say that he then had a major religious conversion in Florence, and that in a way took all his heart with time. It was a gradual thing. And so he ended up becoming a priest and a bishop, and then shifted his career once again, first from anatomy to geology, and then from geology to religion. And he became a full-time bishop in northern Germany.
I wanted you to try and zoom out and deconstruct the lessons that young professionals can derive from Steno's career.
Yeah, so I think it's very interesting because I do that in my book. So Steno, before he goes into the University of Copenhagen to study medicine, you see that he has a deep passion for mathematics. But people and his mentors tell him, look, you shouldn't go pursue a mathematical career in the university because there's not going to be many jobs. I mean, it's not clear the reasons there, but he's clearly pushed to go into medicine, as many people are today still, right? And he became incredibly successful at it. But he started shifting his medical studies and his research, the things in a way that he was pushed to do, towards the things that he liked. And in many ways, I feel, it's a parallel thing to what happened to me as I was doing, studying physics, but increasingly more interested in the history of science. And so Steno, in his anatomical research, studying the glands, he describes the glands as filters of blood, which is a mechanical, very innovative description of it, building on the circulation of the blood, the groundbreaking discovery of this time period. And he was increasingly using more and more mathematics, right? So, for instance, he explains how is it possible that human beings can cry so much, right? The ancients used to say that, it's because all the water is in our brain, in the cavity of our brain, which in a way makes sense. Where does all this water come from? And Steno says, no, it comes from the circulation of the blood. It is chemically filtered out in the glands, the blood, and the quantity is because of the speed of the blood. So he's using basic arithmetic, but quite innovative at the time that he's applying that to anatomy. And he's increasingly more and more using mathematics into that, and he's making groundbreaking discoveries in anatomy. Another one is a new biomechanical model of muscle motion. And he then applies all of these techniques to geology. So it's like a background that he had there already, a toolbox, that when he decides to do research in geology, which we can talk about that if you want more, why he did that, he already has all of those tools, and he applies them and makes him very successful there.
So on this point, how did he get interested in geology? Was it serendipity? Was it planning? Or did he just discover an insight and geology happened to be the field?
Yeah, so I think this speaks to the breadth of knowledge that scholars in the early modern Europe used to have, and Steno definitely had that, because it was not unusual for physicians like Steno to think about these topics. His professors had been writing about this specific kind of fossils, with different kinds of theories. People said, no, these are not teeth of shark. Others said, yes, they are. So Steno was very much aware of these debates. And why? Well, because he read broadly, because his training was a broad training, which included natural history, topics that we today call geology, but geology didn't exist as a discipline. But because he had this broad awareness of how the world operates and the questions that people were debating, again, mathematics, chemistry, theology, he was trained in that as a physician would be in Lutheran Denmark. And all of that kind of plays out into, his turn to geology, which happens in Florence. So he's asked to dissect a huge shark that is found in the Mediterranean Sea, so a great white shark. And as I was explaining, there's like these big anatomical theaters people would go and see. It's an event, right? And so he was dissecting this shark, and he was looking that there was the teeth of the shark were incredibly similar to these stones found on dry land. Someone has a great image of a shark. Look, you should use this image. A great scholar, I won't go into it now. You should look into this image and use your image in this book. And this image comes from this manuscript that's never been published, but you should look at it. He reads the manuscript, and the manuscript says, look, fossils look like teeth of shark, but they're not the same. And yet he said that he was using, the author of this manuscript was a great prominent physician from about 100 years before, which is a short time period in this time, in the early modern period. It looks like it was a while ago, but not that much. And he, finds his methods and his research methods completely challenged there, because he reads an author saying, look, I'm using the same method, but I'm reaching a different conclusion. Let me prove it. He decides I need to prove him wrong. But he's only able to do that because he already had all these tools and all this formation that is now just, triggering that and focusing that into a new research path, which proves very successful.
I wonder if that's still the norm, or are you seeing the push towards specialization take this joy of learning across disciplines away from many people?
I think so, and that's certainly behind my shift away from physics, because I really enjoyed, again, learning the secrets of the universe. I studied cosmology. I remember going into like quantum mechanics 3 and thinking, well, okay, quantum mechanics 1 people have, most physics students will have, but number 3 is just already learning secrets about the universe that almost no one else knows, right? But then when the the end of your program reaches and you decide, okay, so are you going to pursue a career in physics, right? Pursue a PhD? Like the options that were in front of me, I didn't find them as attractive, because you'd be either programming, as many people are doing in cosmology, you have this model and you program that, which is a fascinating thing to do if you like it. I just didn't feel attracted to that. Or you'd be talking about your research to a group of people, but if people were not working on the things that the exact field that you were doing, very few people would understand that, right? And so I found the history of science attractive, because you can still bring a level of excellence and scholarship into that, but you can make it more easily relatable to people. And I think that's certainly a path that I've seen many historians of science take, some of my colleagues. And certainly the great historians of science of the 20th century, which is, again, history of science is a modern discipline, were scientists who then shifted into this world of the humanities. And I think that's fascinating. Again, they did that because they had their formation beforehand.
And you said that this was a common feature among scientists at the time. What shifted? Do you have an educated guess around that? This overzealousness about specialization?
Well, there is the old good answer, which is, we just became more and more experts on this thing, and then you have to go even deeper. I remember when I finished my physics master's, I went and did an internship in a top neuroscience laboratory in Lisbon called the Champalimaud Foundation for Neuroscience. And I remember talking with one of the PIs there, who was also a physicist. Many physicists were there, and he was telling me, look, if you want to do something new in physics, you have to dig deep into, I don't know, quantum mechanics or cosmology, and then in the specific theory, and then maybe you'll be able to do it. Whereas in neuroscience, he was telling me, this was like 15 years ago, it's a whole open field, so there's much to do still, right? The thing about the specialization in the physics shows it well, is that you need to really go deep into that kind of specialization, and you'll need to learn more. The thing is that you can still pair it with a humanities course. I remember when I was at Johns Hopkins, my students, most of my history of science students, were people from the sciences, and I think the history of science actually has a good point to make, because many of these students were scientists who had to take humanities credits, and so they thought that the history of science was the closest thing to what they did. But but it was good history. They're not learning new computational techniques. They were learning how Newton founded the gravitational law, or Galileo, or anything else. So I think there's much to do, in learning, in opening up your scope once again on our modern times.
Fascinating. Can you talk a bit more about the role of friendships and collaborators in the evolution of these very interesting and innovative ideas that came about?
Yeah, thank you for asking that, Utkarsh, because I think we've been telling a lot about competition and how competition drove new ideas, and that's true, right? And you can think about Newton developing calculus and fighting against Leibniz, who said he had developed calculus, who was right. And people would, throw attacks at each other and hate each other, priority disputes, right? But there's another story to be told, and it's very rarely told, and that's what I try to do, which is a history of friendship and co-authorship and collaboration. And I think that Steno, the guy that I wrote my first book about, tells that story very well, because as he moves on to Leiden, he immediately connects with people who think alike but have different kinds of expertise, especially mathematicians. Remember, he liked mathematics, so he pursued the top mathematicians in the places where he were, first in Leiden, then Paris, then Florence. And these places had amazing mathematicians. If there's one thing that we think about of this time period, the scientific revolution, is great physicists and mathematicians. And mathematicians and physicists kind of were about the same group at this time. So he connected with them, became friends, and they would work together. And we know that he influenced other people's works and vice versa. And so friendship, or collaboration, when it becomes friendship, it's very interesting because of another extra thing which I'll just add, which is if you find out that a friend of yours is writing about similar things, then the debate about who did it first kind of becomes more more horizontal. People don't start debating because you're friends with this guy, right? Okay, had I known this before, I'd have mentioned you. And it's very interesting to see these dynamics at play, because they lead to a proliferation of ideas in different parts of Europe, as it happened with this guy.
It's fascinating. Talk to me about religion and science a little bit, because we notice in his career,
Yeah.
the protagonist in your book, that religion comes in at a very important stage in his life, and then he changes his career again. But many people think of religion and science often at odds with each other. What's your comment on it? What does your research tell us about it?
Yeah, so I should say that I write more about science and religion for the broader public than I do in my research, but because that's something that I like to teach people. And why is that? Because people have the wrong idea about how science and religion interacted in the history of science. And so let me just use this as an opportunity to mention my Substack, which it's called Stories of Science, where I often write not just about the history of science, Einstein, Steno, Galileo, but also about science and religion. One thing that I like to tell people when they're new to the field is that we live in a world where science and religion are opposite to one another. But that's a 19th century construct. It's an idea developed by some people who had an agenda against religion and also to promote science, with modern science. The word science is a 19th century invention, at least as we understand it today. And so many ideas that, for instance, that Galileo was condemned for holding scientific theories and shows that religion is against science, were promoted at that time, the whole Darwin conflict and evolution. But in my time period, what you see is that you cannot just impose a modern idea into the past and think it's right? You have to go to the sources and see how it is. And all of a sudden you start to see, well, actually there's not much opposition between science and religion, and there's different kinds of interactions, right? And it's the role of the historian to try to understand what interaction. It doesn't mean that they're all harmonious and they're all, work towards each other very well. It means that in one case it's this way, in another case it's this other way.
Galileo, who you write about in your Substack, the latest story.
Yes.
I think he had quite a tricky relationship with the religious authorities.
Indeed. Well, let me show you the role of the historian here. So basically, Galileo is indeed condemned in 1633 by the Roman Inquisition for holding that the idea that the sun is at the center of the universe and not the earth, right? Which is the heliocentric Copernican model. Now, you can say, see, this shows that science is against religion. And at the surface level, at superficial level, it looks like it does. But if you dig deeper, there's many things that complicate the story. One is that of the committee of cardinals who was supposed to accuse Galileo in the Inquisition, many of them did not want to sign the condemnation. And you wonder, well, if these are religious men, why didn't they condemn Galileo if religion is against science? It complicates the story. Another thing, the Copernican theory, right, that the sun is at the center of the universe, was published by Copernicus, Nicolaus Copernicus, 90 years before Galileo was condemned. And it circulated around. It raised no problems whatsoever, certainly not with the Inquisition. And so you wonder, wow, what happened in these 90 years? Well, that's the job of the historian. That's where we come in and we tell you the story, right? I mean, that's I teach a whole course at Oxford, and I used to do that at Johns Hopkins as well, about the Galileo affair. But just to show that the history, that science and religion is much more complicated. And one final thing that shows that it could actually be the other way around is the fact that when Galileo, in my Substack, I wrote about Galileo's drawings of the moon, right? Because Galileo sees mountains in the moon for the first time, many new things, and he publishes them in a book called the Sidereus Nuncius, the Starry Messenger, in 1610. Now, everyone is overblown by this book, because he's the first person to point a telescope to the sky, sees many new things, but no one can replicate that, because no one has telescopes like Galileo, and if they do, they're not as good as Galileo's, right? And so how does the paradigm change? Well, it's with a group of Jesuit astronomers, so religious priests, right? It's a new religious Catholic order, who are, some of the best mathematicians in Rome. And they are able not only to reproduce a telescope as good as Galileo's, maybe even a little better, and they confirm all of Galileo's observations. And what do? Well, they invite Galileo for a party. They host a major party at the main headquarters of the Jesuits in Rome.
Like the balls we have in Oxford.
Like the balls, yeah. Well, it just meets the telescope in the middle of the quad, but that's the way it would be, yeah.
Yeah, fascinating. So what is the broader lesson? That it's more complex, I get it, but what I gather from your point here is that science and religion move hand in hand, can be contradictory, can inhibit one another's growth, but that doesn't need to be the accurate reading.
Yes.
That many times is the superficial reading. Is that fair?
I think that's a fair account. Yes.
Okay. Even Oxford, like this place started out and is fairly religious in many aspects. But we see both the history of knowledge and the history of Oxford, see the concomitant revolution of both of them. Let's turn a bit to the methods in your book.
Yeah.
How did you go about putting this entire book together? How did you structure it? And is it an extension of the methods from your PhD or something else?
I think yes. I think that's what the PhD should do, right? To prepare you to do what you'll do as a
as a scholar,
competitive researcher, right? And doesn't mean that PhDs always do that, but hopefully they will. And I certainly was prepared to do that. So I see the writing of a book process. I mean, you have your own story, which I'd be very interested to know about. As you have a big business project and you just have to, or any big project doesn't have to be a business project, but how do you tackle it? Well, you split it into small projects, right? Which are the small chapters. And then what do you need to do for each chapter to be written, right? What's the story that you need to tell in each of the chapters, right? And then you have a variety of sources. So for instance, my first chapter is about Steno's student methods and how he studied, how he took notes. And lucky enough, we have his student notebooks still preserved. The notes that he took as a student in Copenhagen is now in an archive in Florence, part of the same collection as the Galileo manuscripts. And you just sit with it and you read it and you try to understand how he did it. And I must say that it's a very hard thing to do because you have to know Latin, right? You have to know Italian. I mean, you have to know some of the language of science in the early modern period. You have to know paleography, which is to be able to read the handwriting that you're not used to do, right? You have to learn all these things. But even when you know these things, it's still a very complex manuscript because it's a student notebook. Think about your own student notebook in college, right? And so it was so complex that Steno himself called it the chaos manuscript. But as I argued, there were some uses to the chaos, and you can see patterns in the way he took his notes. Just like when we look at our own notes, and we find them sometimes a mess, but we know the order. We know how a room is ordered and all these things, right? So you can see what Steno was interested in, what was not, what helped him further in his work by, having a close analysis of these manuscripts. So this is just an example of what I did for chapter 1. Other cases involved searching for all the Steno correspondence, trying to figure out not just the letters that he wrote and the letters that people wrote to him, many of which were already known, but I think my really contribution was to find all the letters that people wrote about him in his lifetime, which is, very thankful. The Oxford Early Modern Letters online catalog has them all incorporated into their database.
So you looked for them through that database?
No, so they were not known, and they were incorporated now. They're now incorporated into this massive,
How did you figure this out? This is a very complicated task to write.
Well, you just go around, archive from Rome to Florence to Pisa to Siena to Milan, to Venice to London. There's letters of Steno or about Steno in London at the Royal Society archives, Copenhagen, and so that's the job of a historian. You basically follow the footsteps of your actors.
Right. How much was this? This is in the pre-AI era. So do you feel that your research method would be slightly different now that you have some of these tools which are fed on a lot of this data?
I think it can accelerate some certain components, but as with almost everything, including social media and other things, the actual effect that it has is not as big as you'd think. So, for instance, you can ask AI to, any LLM can now read a 17th century manuscript and broadly discern what it is about, right? But when you go into the details, you'll see that it's actually getting some words wrong. So it gives you the broad scope, but when you need to actually do the details, which is what a good historian should do, understand, who's writing to whom, what ideas are being passed there, what are they talking about, then you have to do the work yourself. The AI will not help you there. Again, because the AI is trying to impress you, so it's not going to the little details, and that's really the job of the scholar.
Yeah, and that's why AI can be very helpful if you broadly know the subject, and if you know
exactly.
how to prompt it, how to, you have a sense check, that, hey, this does not feel right, let me push this a little bit, and then AI can perhaps aid you, but you do need to have an intuition. When you read all these correspondence, so I think method also, you don't start with a method and just start implementing it. Methods evolve.
Yeah.
What were some of the lessons that you draw when you started, looking at the letters? Because writing a book is also leaving out a whole bunch of stuff that
I
you
agree.
wish you had space for.
Yes.
So
Yeah,
how
yeah.
did you go through that process?
Yeah, that's a challenge, writing a book, teaching a class, only have 50 minutes. What do you teach your students, right? What's going to be left out? All these questions that, university professors have to deal with all the time, and book authors are fascinating, and people, have different ways of doing it. And I think it speaks a ton about your capacity, Uktar Shivan, of putting ideas between two covers. That's a huge task. Well, one thing that a researcher can do is to use that material that's out of the book and publish it as articles, book chapters in other books. All of that will be very helpful. And you have a Substack. You know how Substack authors do it. Everything they write, they try to use it to put to a good end. And so nothing is left out. And you try to think about how to twist it or something, right? But it has to have what stays in. Needs to have a really solid narrative, right? It has to have a beginning and end. It has to have a new argument, a story that you need to tell, made of multiple small stories, but they all together had to lead you to one story. And that's what I did with The Traveling Anatomist. And that's what book authors keep on doing to this day.
Yeah. Why did you title it that, The Traveling Anatomist? Or rather, what are the other titles you experimented with before you zeroed this one on?
Well, I thought about, the intersection of disciplines, interdisciplinarity, which is a buzzword that I'm not especially fond of because it projects modern ideas of the present into the past. So I actually used the intersection of disciplines in the subtitle. But The Traveling Anatomist, I think, is really the core of my argument, is that this guy's ability to, use mathematics in the human body, which is, again, a groundbreaking thing, to, tell a new history of the Earth with chemistry and mechanics and mathematics. And then his later career shift into theology, which is not as important for this story now. But these whole scientific contributions were only possible because he was on the move and he was publishing things on the move, right? Many people traveled back then, and we still travel today. We're here in Oxford, but neither of us is from Oxford. We came here to study, or I'm here to work, right? For my research. I've been in other places before, and even when you have a permanent position, you have a visiting professorship elsewhere. So interactions with other scholars, travel ends up shaping the questions that you're interested in and how you answer them, the methods that you use, the ideas that you have with the colleagues that you were spending time with, right? We think modern science is definitely like that, but we may fall into the mistake that thinking it was not like that back then, and it was. You go to the 17th century, everyone was traveling. Like William Harvey, the great physician who discovered the circulation of the blood from England, right? He was warden of Merton College here at Oxford in his later life. He studied anatomy at the University of Padua in Italy, one of the best universities to do so at the time. Now, one thing that Steno, my guy, has different from the other ones is that all the other ones, they traveled, then went back home and produced everything they did back home. My guy was producing things on the road. And I think that speaks a lot about how he was able to actually incorporate different disciplines and mix them up into very focused problems. I also want to stress that it's not that he was very broad and doing everything. No, he was focusing a breadth of knowledge into very specific problems. So what I'm calling focused interdisciplinarity, right? He's using many disciplines, but focusing on to tackle first the glands, then the heart, then the muscles, then the ovaries, then the earth, right? And I think that's very interesting. But it speaks also about how travels were shaping his research.
So two follow-ups from this. One is let's dive deeper into travel, because now people substitute travel for Zoom. You and I are in the same room right now in this gorgeous college, but there's Zoom, there are other kinds of resources. How much of that traveling can also happen online, in your opinion? And then I'll ask my next follow-up, which would be about the other scientists that were there around this era. How did they either do focused interdisciplinarity or not?
Yes, that's a good question. So Zoom, that's a good question. I think it's very helpful. There's many things, there's many meetings that you need to have or that are good for you to have that are not essential, they're not essential for your career. They may, give you some insights, some things. And even if they are essential, maybe just asking a question to someone who'll be able to call it, get a Zoom call. I think that's okay, and it speaks to our modern world. I don't think that substitutes travel and the advantages of. And by travel, I mean meeting people in person, going to a conference, sharing an office with someone, visiting, going to give a talk elsewhere, right? Because, it's different for you to give a talk to an audience than to a Zoom thing. You can feel your audience when they're in front of you, whereas on Zoom, that's harder, right? That's important about how you think about your ideas, how they're being received by an audience. If you're a scientist, I mean, doesn't compare to do an experiment together, right? And doesn't need to be an actual lab experiment. It can be, sitting next to one another, doing a mathematical, solving a mathematical equation and sharing notes, right? There's something to that experience that triggers new insights. That's true. You can get that sometimes on Zoom, but it doesn't. It's not the same thing as being in the same library, doing this kind of work.
It's a lot like AI, right? AI is also helpful.
Yeah.
It's just not a substitute.
Exactly.
A lot of these technological tools can be really helpful, can in emergencies be a substitute, like maybe the pandemic, but one should maybe strike a balance. Focused interdisciplinarity is something that I want to double down on now, because this is something that people struggle with all the time.
Yes.
People who have multiple interests, sometimes those multiple interests, they think of it like a burden. Sometimes the education system makes you focus so quickly that you don't know what are your other interests. And then life comes up and there's always something else. Help us define this term. Talk to us about other scholars or scientists who've done this well. And maybe from your life or research, you've stumbled on people who've not done it well.
Yeah. So it's an interesting question. I think that's another of the major interventions I'm doing in this book, because it's very common to talk about the 17th century as the golden age of polymaths. Because, people had this broad education, and it seems that everyone did everything, right? You think about Newton. I mean, he's a great physicist, but he also did a lot on mathematics, pure mathematics, calculus. He did a lot on chemistry. He did a lot on theology. If you look at another example for the science and religion thing, like if you look at everything that Newton wrote and you judge who he was by the quantity, you'd say, this guy is a theologian. He's not a scientist, you see, because he wrote way more on theology than he did on physics.
I did not know that. Thank you for telling me.
Yeah, so he had, he had these multiple interests, right? Then he had someone like Leibniz, who actually wanted to have, a science of everything, a general science of everything. That's a great mathematician, great physicist, but wanted to bring them all together. Just Newton and Leibniz, for instance, are very different people. And if you say that, they're just polymaths, you're missing out on something, because what are the reasons for them? Leibniz really wanted to bring everything together, whereas Newton, he was working on these different things in parallel. Like, it's not that his chemistry was influencing his mathematics, which vice versa was not influencing his theology. Towards the end of his life, yes, they did. And you see a little bit of chemistry in the latest editions of the Principia and of his books on optics. But that was not the way they originated, it's just different interests that he has. None of this, I think, matches the focused interdisciplinarity that Steno and some of his peers did have, which is, yes, you have a broad range of knowledge, but what you'll do is that you'll apply all this breadth to a very specific problem, right? So Steno starts like that, looking at the glands, right? How do, again, the making of tears, how do the eyes produce the tears, the lacrimal glands, but how does it work? And so he starts using mechanics, filters, thinking of the glands as filters of blood, drawing in from his mathematical work on the speed of blood flow, that the lacrimal fluid is hidden in chemically mixtured within the blood. So you see chemistry coming in now, right? So he knows all these things, which he received from his training, his formation, but it's not that he wanted to know everything. This is the way he was trained, and now he's just collapsing everything into different problems. He still struggled with it. Later on in his life, as he was writing his final book on geology, he says that all these research projects felt like a hydra with multiple heads. If you cut one and another would appear. But that's the life of a scientist. You solve a problem, and then you discover there's something else that you need to discover, right? And that's why I think science is such a fascinating thing.
I wonder what kept him going, or what do people do to keep going? Because this hydra can be intimidating.
Yes, well, one thing that at least kept Steno going, but I think also many other scientists, is what I am terming the search for certainty. He was obsessed with certain knowledge. Because as a physician, he was reading many books about medicine, about anatomy, that he felt were not good. They had errors, and claims that were a bit probabilistic were not, stated as such. And he said, this is a mistake. I mean, we're using this stuff to heal people. We cannot do that, right? And this is also a relevant question, I think, for our world of AI, because it's so easy, and AI can hallucinate and tell us things that a non-expert will not know. Steno, who was the expert,
certain way.
Yeah, in a very certain way, trying to convince you. You're absolutely right. Steno realized that, but he was an expert. So a big example is Descartes, right? Descartes wrote a book about the human body. It's called Treatise on Man. And Steno read the book, and he said, these are his words. He says, this book has beautiful images of the brain, but the images don't match the reality that I see on my dissections. So he writes a whole book just demolishing Cartesian physiology. It's not that he brings anything new. He thinks that just showing that this new research being presented as certain is actually not certain, is bringing value to science. And in fact, the book was a milestone because every other anti-Cartesian in the 17th century and 18th century would go back to this book, especially on Cartesian anatomy, where Descartes really got it wrong. But it speaks to the search for certainty, the search for truth that should animate science. And I wonder how much it does today.
Is it the search for certainty or is it uncertainty reduction? Because I feel that search for certainty, could it bog you down to an incorrect truth because you just want to eliminate all uncertain elements?
I think it's both. There's the two faces of the same coin, right? And one thing that Steno does, he has books where he shows like these new claims are false. Let me show you why. But he also has books where he shows, look, I've made these discoveries. That glands seem to work as filters, or that the earth, the sediments, the strata, could have made in this way, right? But I'm not absolutely certain they were this way. But look, I have this mechanism, this other mechanism, and however you think about the world, my mechanisms will work, right? So this is kind of a probabilistic argument, but he qualifies it, right? He says, look, I'm not absolutely certain, but how would you about the history of the earth? We don't have access to it. That's how most science is done. But as long as you're clear on the level of certainty that you have, that's, I think, very interesting. That became super important for his religious conversion, for example.
Among your students, other scientists that you've studied, or people that you know, when does this, what was the term? Focused interdisciplinarity seem to backfire, or people are not able to make most of it?
Well, it's when I think you get distracted by too many tasks, right? You have too many projects, you're trying to do many things, which is hard, especially, including for a university professor like me, but I can imagine a businessman like you and an entrepreneur has different ideas. You have to focus on the project. Otherwise, you'll be missing out on the main task that you'll be supposing to do. But now as a researcher, we have teaching tasks, we have research. How do you decide where to dedicate more time to? And even in research, you have many ideas, right? Which should you pursue, right? So I think the most important thing is that you make these decisions, right? And then you focus on following that path, right? Then things will move you on to another path, another Hydra head will appear. Right. And then you make the decision again. It doesn't mean that you'll solve the problem forever, but you have the way to solve it.
Yeah. This is fascinating. If hypothetically you were to argue against your own thesis, what could be some probable alternative explanations?
Against my own thesis? Yeah, that's a good point. That's a good question. I think there is a case to be made that some people may have been successful at using, being scattered in doing things. I mean, Leibniz certainly has a tremendous amount of work, most of which is true and correct. He did discover calculus. His dynamics is not Newton's dynamics, but it's very compelling. And I guess he would have to have an ability still to be able to, discern his time. And Steno, in a way, had to deal with that as well, because especially when he decides to study theology more seriously, he has to block all the morning hours to go into the Medici library, read old manuscripts, and then in the afternoon he'd do dissections. And there he was juggling too with geology. So this was a complicated moment in his time, but it still bare fruit. He found some religious peace where he was searching for it. It was successful in geology in his mathematical book too. And he was just a little bit more scattered, but then he found his way again.
A question I forgot to ask you earlier was that, do we know anything about the family lives of these people? Because if you're traveling this much, I would imagine that you may not have a particularly stable family life, but maybe I'm wrong.
That's an interesting point. I mean, we know about their upbringing, right? In stable homes, I mean, Steno's in particular was a bit more troubling because his father died, then his mom married to someone else, his stepfather also died. So it was a hard infancy in a sense. But then, as I said, most people would travel, but then they would go back home and settle down. That didn't happen with Steno. Now, one thing that we don't often consider, but is that many people were actually celibate, right? I mean, Newton didn't marry, and he didn't want to marry. And in a way that gave him more time. I mean, all Oxford dons, right? Until the late 19th century, early 20th century, all Oxford and Cambridge professors were not allowed to marry. Even when the Church of England, which is the main church of the UK, right, was already allowing priests to marry, the professors of Oxford and Cambridge, which were mostly sometimes ordained priests, could not marry, right? And so there is some certain connection with the idea that, if you want to pursue a competing research career, you won't have time for the family life. Now, that's not the case for everyone, and thank God we now have other things. I'm very blessed to have a wonderful family and wife and children, but it does mean that I have to think more carefully about how I organize my time, perhaps more carefully than the old Oxford Dons would.
Yeah. We've covered a lot of ground today, discussing about a relatively lesser known scientist and the way he went about and what we can derive from the way he did scientific research, the way he approached scholarship. We looked at focused interdisciplinarity, we looked at friendship, family lives, looking at learning across disciplines. This makes for a fascinating reading. But I wanted to ask: is there something that we should have discussed but we haven't discussed so far, or a point that you wanted to make about the book or your broader career that we haven't touched upon thus far?
Well, that's a good question. I mean, I think it is an important thing. I would also be interested in what you think, Utkarsh, but how do you make cutting edge research, not just in history of science, but also in physics or in finance, which is what you do, reach more broader public, right? And I think that's part of both of our works. I mean, with this podcast that you have, but also with the Substack that I have, is a way to make, big ideas reach the broader public. And I think there's something to it. And not every academic is able to do that. And I myself, I'm still learning the craft.
Mission 10,000.
Exactly. Yeah, let's go that way. But why is this important? This is not just because for the sake of subscribers, just because you're passionate about what you write about, what you love, and you want to tell people about this. And one of the things for me as a scientist, or originally trained as a scientist, was, the story that I was told about the history of science was very different. It's not just a story of geniuses, it's a story of collaboration, of friendship, of travel, of, where religion plays a role, where craftsmanship plays a role. And I think that's fascinating, and I want more people to know more about it.
Yeah, and just for our listeners, the Project 10,000 was just my funny reference to Nouveau's decision to try and reach a 10,000 followers, not necessarily because he needs it, he's pretty established in what he does, but because he's passionate about the ideas that he touches about. And before closing, any other projects that you want to talk about or you want our listeners to know, because people listen to this podcast from far and wide?
Well, I'm right now working on a new book, but I'd love to be back here to talk about that, which explores some of these questions, but with a broader range of characters in the Mediterranean world. So it includes Galileo, William Harvey. Why were people? I'm right now tentatively entitling it as expanding expertise, right? Why was Galileo interested in animal motion and in animals? I mean, he was not an anatomist, right? He was. We know that. I know that he was.
These would be very successful business books as well, by the way.
Yeah, well, that's something that I'm interested in. Another topic that I try to write a lot about in my Substack, more than in my research, is the role of women, in the making of science, which is...
Can you share more about it?
Yeah, I mean, I'm sure many of your listeners have seen the Hidden Figures movie, the NASA, the women at NASA. So this movie talks about, these computer women who are making all these calculations, right? Which is remarkable because very few people had known about this, right? And we tend to think that science is a thing made by men. And in a way it was. But when you look at history more carefully, you start seeing women in various places that you're not expecting it to. So for instance, with Steno, my research, this is what my final chapter is about. I was trying to understand why Steno converted to Catholicism, because that's what happened to him in Florence. And it had to do with a woman that had a certain influence on him, a very devout, noble woman. And he met her through his physician friend. And then you start, but how can, this devout, noble woman from Florence have such an influence on this great intellectual that's visiting Florence, right? And then you start looking more carefully at these letters that I was finding, and you start to see, well, there's actually this other woman who actually spoke with him. And this other woman that spoke in Paris, in Leiden, even in Copenhagen, and other in Florence. And then you start to realize, wow, who are these women? How is he meeting them? And he's meeting them in the scientific circles of Europe. And very few people have told this story. Like, let me just share this with you, because very few people know that the first woman to have a university professorship was in 18th century Bologna at the sponsorship of Pope Benedict XIV, who also sponsored other women. Maria Gaetana Agnesi, the first professor of mathematics at the university, Anna Maria Manzolini, professor of anatomical design at the University of Bologna. All of this happened in 18th century Italy, right? No one has heard this story, right? Sometimes we hear of some women, Margaret Cavendish in England, even those are very poorly known. But, all the Southern European world, has a fascinating story to be told about women in science and education, which I think is remarkable.
It most certainly is. And is there this Hendrik Owens project that you want to discuss?
Oh yeah, we can talk a little bit about that, because so this is a story. When I moved to Johns Hopkins, one of my pitches to be, that I was a good historian of science, I could be trained in that, because again, here you have a physicist pitching yourself to a history department, basically. How can this guy do history? It's not a given, right? So I had to show them that I could do some of that. And I had been working on some 17th century manuscripts in the Portuguese National Library of some mathematicians who were teaching mechanics, mathematics, hydrostatics in Lisbon, who then went on to the Portuguese Empire. In particular, these were Jesuit priests who were very well trained in mathematics, as I already mentioned in the Galileo part. They'd stay in Lisbon for a few years, teach there, and then they would go on to India, to China, and where their mathematical skills would be very important. So Henrik Uvens is the guy that I wrote my first research paper about. He was teaching, Galilean ideas, about the vacuum, groundbreaking ideas in Lisbon. And then he boards a ship in Lisbon and follows, around the coast of Africa all the way to India. He wants to go to China, but his Jesuit superiors tell him when he gets to Goa that they need him in the north because they were making strong connections with the Mughal Empire. And he moves to Agra, and there his mathematical skills become very attractive to the Mughal court, and he sees the Taj Mahal freshly built, right after it was built when he gets there. And so I write about what I call the mathematical backstage of a normal missionary. Because those who study the history of Jesuit missions or of missionary histories have heard about this guy, but look, he has a fascinating science, mathematical background that no one knew about, so that's what I tell in my
that's
article.
been the most riveting part of this discussion, how much social networks, friendships, the history that has been forgotten matters in the study of what you do. And I think you've also done a fascinating job of explaining to us why this research matters and how we should pursue this entire field. Thank you very much for doing what you do. Where can people find you?
So people can find me on LinkedIn and on Substack, Stories of Science. So it's Nuno Castel-Branco.substack.com. You can find me there.
And your book?
And my book. And of course, my book, The Traveling Anatomist, which is available on any Amazon that you want. And if you read it and if you like it, I would be very thankful if you'd leave a review.
Absolutely. And please do check out this podcast. Send us your thoughts, and we'll be perhaps planning a history session or history of science session or a lecture series with him. Stay tuned for the next book. Thank you very much.